Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 2, Section 1, Variables and Algebraic Expressions. So we're going to start with a few vocabulary terms that you need to know. First, a variable. A variable is simply a letter that we use to represent a number. Well, quite often we use X's or Y's, but it could be any letter. A constant is simply a number. It does not have a variable attached to it. Like looking at an example, if we had 7x squared plus 3x minus 4, the variable in this expression is x. The constant, this negative 4 does not have a variable on it, so this would be the constant. And this next term is coefficient. That's what we call the numbers that sit in front of the variables, and they are being multiplied. That's how they're connected to the variable. So the x squared coefficient in this case is 7. The x coefficient is 3. An algebraic expression is simply a mathematical expression that has numbers, variables, and operational signs, meaning like adding and subtracting, multiplying and dividing. What an algebraic expression does not have is an equal sign. Okay. When it does contain an equal sign, then it's called an equation. So please note that distinction. When you're asked to write an expression, it does not have an equal sign, like what we wrote up here, this 7x plus 3x minus 4. Just an expression. We cannot solve it because it doesn't equal anything, but we work with expressions to help us learn the language of algebra. All right, the next term we're going to look at is the word domain. Now we're just going to begin our study of domains. This is something we'll be discussing a lot during Algebra 1 and 2. In this section, we would call it the input. In other words, it's the numbers that we're putting into the expression. We're taking out the variable and putting in these numbers. So a domain is a set, so we do use set notation. The set of numbers used to replace the variable. And we'll look at an example in just a moment. Next term is range. The range then is what comes out of the expression after you have put the domain number in and you do the math, whatever the expression is telling us to do, and then you get an answer or an output. So the range is a set, the answers you get as a result of putting in the domain numbers into the expression. Like I said, we'll look at an example of this in just a moment. Now this is a review from pre-algebra. You need to know these words and what operation they mean. This is so that we can translate from English into an algebra expression and vice versa. So just take a moment and write these down and know that these are the words that mean add, subtract, multiply, and divide. Please be sure to make note of this word of. That's going to become very important in our chapter that we do on percents. So please note that the word of does indicate multiplication. And now for some examples. We are asked to evaluate these expressions for each member of the domain -5, 2, and 3. So one at a time, we're going to take those elements of the domain and we're going to put them into the expression. So first of all, let's take the -5, and where we see this x right here, we're going to take out the x and put in the -5 and then add 15. And if I did that right, it's 10. So I guess I'll put the set here of the range. The -5 is the input, the output is 10, so that's the first element of our range. The next element of the domain is 2, so we put in a 2 right here, and we get 17. Same thing with the 3, put the 3 in for the x, and we get 18. So we had an input and an output. All right, likewise for example 2. Let's take the -5 and let's put it in where the y is. And then sometimes I call this step do the math. So then we take, let's see, that'd be -15 minus 8. So the first element in this range would be -23. The next element in the range would be the answer here would be put in the 2, and that would give us a -2. So I'm going to put that in the range. And then when we put in our third element, we put the 3 in here, we get a 1. All right, now let's put the 3 elements of our domain into example number 3. So when I put in the -5, please be careful. -5 squared is a positive 25. And so if you multiply that by 12 and subtract 9, you should get 291. So that would be the first element in the range. Then we put a 2 in here. 4 times 12 minus 9. If I did that right, I got 39. So we'll put that in. And 9 times 12 minus 9, I got 99. All right, so check that math. Make sure you agree with those elements in the range. Now we are asked to translate these words into an algebraic expression. So reading number 4, the number of pennies if there are 5 more pennies than nickels. So what I like to tell you is choose your variable to be the thing that you know nothing about. Now we know that there's 5 more pennies. We know nothing about the number of nickels, so I'm going to call the number of nickels x. And then I know that there's 5 more. More indicates adding. So if there's x nickels, there's 5 more pennies. That would make it x plus 5 for the expression. Number 5, the length of a rectangle, if it is 10 inches longer than twice the width. I know nothing about the width. I know some details about the length. So you can pick this to be any variable you want. Perhaps you thought of w for the width. So if the length is 10 inches longer than twice the width, so first we would want to write twice the width, which is times 2. And then 10 inches longer would indicate adding. So that's the expression for number 5. Number 6, the number of girls in Mr. Olson's class if there are 3 fewer girls than twice the number of boys. So we have some information about the number of girls in the class. I don't know anything about boys, so I'm going to call that, I don't know, X or maybe B in this case. So we know that the girls, there's 3 fewer, so we have a subtract in here somewhere, and twice the number of boys. So let's take twice the number of boys first, 2b. 3 fewer than that would be a -3. Okay, number 7 says the difference between a number and 12 times the number. So when it says a number, again, any variable you want, I'll just call it x. The word difference means subtract. So we want the difference between our x and 12 times that number, again, x. So difference means subtract. Difference between our number and 12 times that number, 12x. All right, now what's difficult to teach about these next 3 examples is that people are going to write them a little differently, and there's many different ways to write this correctly. Number 8, like for instance, I might put twice a number, subtract 5. Someone else could write 5 less than twice a number. That would also be fine. You have to watch that word less, because sometimes when they say 5 less than, that means the subtract is at the end. So this word less, be careful with it in your assignment. Here we want to be clear in number 9 that we're doing this first. And so you could say, no, this is multiply. You could say triple a number z. You could say 3 times a number z. Different ways to say that. 3 times a number. When you want to be able to express that this is in parentheses, you need to make sure you're using the difference of these two. So we're taking 3 times a number added to, or increased, or there's many different ways to say addition. 3 times a number added to the difference of 7 and a. So when you say this word difference, that's indicating that we have to protect this difference with parentheses. And then our last example, again, we have to protect this numerator. You can't just say n, a number, subtract 8 divided by twice n, because then that would put it to look like this. Then it would sound like you're dividing just the 8 by the twice n. So you have to make sure you have phrased it so that this numerator stays together. So you could say the difference of a number and 8 divided by twice the number. Twice that number, twice the number. All right, you get the idea. There is more than one way to write these, and so in class we may have to be reading some of them and evaluating them to see if they say the same thing. All right, now you have the knowledge you need to do section 2.1. Have fun with that.